So we learned what molarity was. Molarity is moles per liter, and now we're going to do a calculation using molarity as a conversion factor. These concentration units are not that complicated. So you need to remember what they are. Molarity is moles of solute per liter of solution. The mass percent was mass of solute per 100 grams of solution. And then all the calculations follow from that as long as you understand dimensional analysis. So using molarity and calculations, determine how many grams of sucrose are contained in 1.95 liters of 0.781 capital M, which we pronounce molar, 0.781 molar sucrose solution. So it's important here to remember what the capital M means. So this means 0.781 moles per liter. In the book, on the slides, on the computer, it's written capital M. On your paper, write moles per liter, because otherwise you'll forget what it is and then you won't know what to do. So always write moles per liter. So we have that, and then we have this volume in liters, and they're asking how many grams. Well, none of those numbers they gave us have grams, do they? But could we convert moles to grams? Sure we could. That's one of those real basic things. So what we need to do is from the two numbers that they gave us, we have to identify which one is the starting point and which one is the conversion factor. So the starting point is the one with the single unit, liters. The conversion factor is the moles per liters. So our path then is going to be liters, and we'll convert to moles using the molarity. And from moles we will convert to grams using the molar mass. So 1.95 liters, and we go times moles, and then times grams. So this middle term we're going to divide by liters, so the liters cancel out. The last term we divide by moles, so the moles cancel out. So we get all the units in place, and then we stick the numbers in. Moles per liter is the concentration. So 0.781, 0.781 moles per liter. This guy is the molar mass, and so we have to calculate that, but they gave us the formula. I noticed in the homework, I think it was for chapter 12, that there were a couple of questions where they didn't give you the formula, they gave you a name of a compound that you don't know how to write the formula for. If you go look in the textbook, you can find the formula, or Google it or something. I won't do that to you on an exam, though. So C12H22O11, this is going to be a large molar mass, isn't it? So 12 carbons, each carbon is 12.01 grams. 22 hydrogens, 1.008, and then 11 oxygens. Keep forgetting to pull up my calculator. Cell phone to the rescue, right? Just make sure you know how to use your calculator. 12 times, well, that's not right. Clear it first. 12 times 12.01 plus 22 times 1.008 plus 11 times 16. 342.3. 342.3. That's a molar mass, grams per mole. So that's our last conversion factor. So stick that in there. 342.3 grams per mole. So we have 1.95 times 0.781 times 342, except I typed it wrong, 342.3. I came up with 521. Anybody else get that? Because I know I made a glitch and I wasn't sure if I got the wrong answer because of that. So 521 grams. So 1.95 liters of 0.781 moles per liter sucrose solution contains 521 grams of sucrose. And this is the sort of calculation that you would do if you needed to make a solution like that. If you needed to make 1.95 liters of 0.781 moles per liter solution, this is how you would calculate the amount, the mass of sucrose to put in the container. And then you would add water until you get to the needed volume. Any questions? Oops. So for molecular solutes like sucrose, the concentration of the solution is going to reflect the concentration of the solute as it exists in the solution. What does that mean? Well, sugar molecules are molecular. They don't come apart into ions when they make a solution. They're non-electrolytes. But ionic compounds, when ionic compounds dissolve, they come apart into ions. So if we say, it's 1 molar sodium chloride solution, that means we've added 1 mole of sodium chloride solid to the water. And what happens to it in the water is that it will come apart into ions. We can estimate the concentrations of the ions, but knowing exactly what their concentrations are is a little more complicated. And that's something you get into in Chem 2. So if we look at a 1 molar calcium chloride solution, getting tangled up here, 1 molar calcium chloride solution. When that dissolves, you're going to get 1 mole of calcium ions for every liter, and you're going to get 2 moles of chloride ions. You see that? Come on, let me draw. I'm going to draw. Come on. So calcium chloride solid, when it dissolves, it'll break into calcium 2+ ions and 2 chloride ions. We get that from its formula. So then the concentration of chloride ions is going to be twice as high as the concentration of the calcium ions. So let's calculate something. So we have a 0.75 molar calcium chloride solution. Determine the molar concentrations of calcium ions and chloride ions in that solution. So there's a couple of different ways that you could approach this. So 0.75 molar means 0.75 moles of calcium chloride per liter of solution. If we want to know the concentration of calcium ion, we can figure that out. We could multiply by moles of calcium ion and divide by moles of calcium chloride. When we look at the formula CaCl2, we see that there's 1 calcium ion for every formula unit of calcium chloride. And so these end up being 1s. And so you're like, well, that was a stupid calculation. It came out to be the same. Well, yeah, it did. So it's 0.75 moles per liter calcium ion. But what about the chloride?